I came to know about you, and I caught him royally, telling that your boss has to give us a keynote address.
Well, thank you for inviting me.
Venkatesh Prasad is my favorite student.
He's terrific. I mean, we're building some amazing software. Julia Computer. Venkatesh is right in the midst of it.
Yes, yes. He was very focused during his engineering days also. So very happy.
Nagraj, make sir as co-host.
Yes, ma'am.
Shall we start in another 2 minutes? It is 4:58 here.
Anna.
Can you all see my screen share?
Yeah.
Yes, sir. Yes, sir.
Perfect.
Yes, sir. We are able to see.
Oh, can you remind me how much my speaking slot is? Is it, I have prepared for a 45-minute talk, roughly?
Yes.
Yes.
Yeah, 45 minutes. After that, we have one more talk.
Okay, perfect.
Shaila, shall we start?
Yes, madam. Yes, madam. We'll start.
Start, ma'am.
Yeah,
Yes.
start.
Okay. Good evening, everyone. I welcome you all to the third keynote session of ICInPro 2021 on Reimagining Technical Computing with Julia by Dr. Viral B. Shah. Now, I request Nagraj, research scholar, to introduce the keynote speaker.
Thank you, Shweta. It's my pleasure to introduce Dr. Viral B. Shah. Dr. Viral B. Shah is the co-founder.
Can't hear you.
Sorry, ma'am. It's my pleasure to introduce Dr. Viral B. Shah. Dr. Viral B. Shah is the co-founder and CEO of Julia Computing, Cambridge, Massachusetts, United States. Dr. Shah is best known for being a co-creator of the Julia programming language. He was awarded with Doctor of Philosophy in Computer Science from University of California, Santa Barbara, and Bachelor of Engineering in Computer Engineering from Padma Bhushan Vasantadada Patil College of Engineering. Dr. Shah was actively involved in the other project and co-authored the book Rebooting India. He has received patent for his work on methods and apparatus for parallel execution of a process. Dr. Shah was awarded with James H. Wilkinson Prize for Numerical Software from Society for Industrial and Applied Mathematics, and he also received the Spatial Ecology and Telemetry Working Group Award in recognition of the contribution to support the wildlife profession through the CircuitScape software. We welcome you, sir. I request you to take over the session.
Thank you for that introduction. I assume that you can hear me all right?
Yes, sir. You're audible.
Thank you. So I'm delighted to be here at ICInPro, and I'm going to talk about Julia, which is one of the programming languages that is increasingly becoming the language of choice for scientists and engineers and data scientists all around the world. And as Dr. Nagraj said, I'm one of the creators of the Julia programming language and also the co-founder and CEO of Julia Computing. But of course, the work that I'm going to talk about has been conducted by the broader Julia community, which includes over 800 contributors to Julia's GitHub project. If you can go to github.com/julialang/Julia, so over 800 contributors there, and then thousands of contributors who have written over 6,000 packages that people use in the Julia community. And so I would like to acknowledge the contributions of all of the Julia community as part of my talk here. It's been an 11-year journey so far. Julia started in 2009 and with an urge to solve the two-language problem. Now you might wonder what the two-language problem is. And simply put, the two-language problem is that, if you're a data scientist or an engineer, many of you might have worked with MATLAB or Python or R, and or one of these high productivity languages, which are very easy to use in order to describe your algorithms and write your code. But you often have to rewrite your programs in C or C++ for high performance in order to deploy them or run them at scale. And it's not ideal to write the same language twice, right? Once in MATLAB or Python or R, and then rewrite it again in C or C++. So if you could have the speed of C, but also the ease of use of Python in a single language, that could be pretty amazing. And this is why we set out to create Julia. In 2012, we published a blog post called Why We Created Julia. So if you click on this blog post right here, let me. So one of the things I'd like to do is also show some of the various different websites and things around Julia as I go through my talk here. Let me make this thing just full screen again. Okay. So this was the post that we wrote called Why We Created Julia, and it became really popular. It was covered all over the internet, and we went from being a 3-person project to 100 contributor project in the very first year. And today, like I said, thousands of contributors. Many of you might be familiar with Jupyter, the Jupyter notebook environment, and Julia became the JU in Jupyter in 2013. You might wonder what Jupyter stands for. It stands for Julia, Python, and R. At 2015, we created Julia Computing because of the commercial interest and demand in the Julia language. In 2017, we hit the first milestone of 1 million Julia downloads. In 2018, we released Julia 1.0, which is a promise that the language is going to be stable for a very long time. In 2019, we hit 10 million downloads, and the project started receiving many of the best accolades that numerical computing folks can receive, the Wilkinson Prize and the Sidney Fernbach Prize. And then, we are now here in 2021 with over 30 million downloads. The latest version of Julia is Julia 1.6, and we are working on releasing Julia 1.7 with very many interesting features. And this stuff is making real impact, right? So Julia is being used for faster drug development by all of the top pharmaceutical companies worldwide. It's being used to develop new and efficient battery technologies, which is something that we are working on with our collaborators at Carnegie Mellon University. We're working with our partners at Mitsubishi Electric Research Laboratory to build energy efficient buildings, where Julia is being used to design new air conditioning cycles. And there are researchers at MIT are using Julia to model climate change and design new algorithms, new AI algorithms for for the agricultural domain. And these are just some of the interesting scientific domains that Julia is part of. But what it really brings together is the ability to combine traditional scientific computing with modern data-driven machine learning. I will say a little bit more as we go forward. But here's the Julia Lang project. So this is the Julia Lang project on GitHub, and let me see if I can actually pull up the web page. So if you just go to github.com/julialang/julia, you will find it. In fact, if I go and just look for it on GitHub, it will show up as the first hit if you type Julia and GitHub. And it should, I was wrong about 800 contributors. I hadn't seen this in a while. It's 1,200 contributors to the Julia project now, and you can see the latest release here. And the project has 800 pull requests, over 3,000 issues. It's that are open, and so on and so forth. But if you're a new user, what I would suggest is go to julialang.org. So the way to find it is if you just type Julia, then the first hit will be julialang.org. And if you go there, you can click on download, which gives you, the latest release of Julia that you can download and install. If you want to install an IDE, which I would highly recommend, I would scroll down all the way here. And, you can install Julia using an IDE of your choice. VS Code is one of the most popular ones, but, Jupyter is pretty well known as well. Pluto is native Julia notebooks. So here's Pluto, for example, and I will say more about Pluto as we go along, actually. Okay, so back to my slides here, and full screen. So one of the things I always like to talk about is that Julia, I actually started the Julia project when I was based out of Bangalore, and we actually had JuliaCon India in 2015. Which is, and this is a team that was working on Julia at that point from Bangalore. And it's just fascinating and amazing to see that Julia is one of those few and rare open source projects where a lot of the mainstream contributors, a lot of the core committers to the Julia project are actually from Bangalore and broadly from India. So this is one of the reasons why we get a lot of students from Google Summer of Code working on Julia. And it's, so if you haven't tried out Julia yet, well, don't wait any longer. Please join the fun. The Julia community has seen exponential growth. Like I said, over 30 million downloads, but on every metric, right? It has been growing exponentially, whether it's the Julia language channel on YouTube, or if it's the discussion forums, or if it's mentions in the news articles, or it's the number of packages in the ecosystem. It's rapidly moving up in the popularity rankings, in the programming language popularity rankings, number 19 on IEEE Spectrum, number 23 on TIOB, and number 24 on PyPL. We estimate that the size of the Julia community is over 1 million users worldwide, and we've seen downloads from over 10,000 companies. It's used and taught at over 1,500 universities, including MIT, Stanford, Berkeley, Cornell, and all of the above. These are some of these, some of the logos of the universities that are using Julia. Of course, 1,500 cannot be fit on one slide, but here's just a sort of small sampling. One of the most amazing things about Julia is the GitHub organizations that power Julia. A lot of the open source Julia projects are set up as GitHub organizations. So, you have users who are focused on ecology, or who are focused on audio processing, or Raspberry Pi, or geometry, or, a language like, the Julia Korea group that translates Julia to Korean, and so on and so forth. So there are over 100 GitHub organizations that develop the thousands of packages that are popular in the Julia community. Now I want to sort of switch gears a little bit from talking about Julia as a language and the community to some of the performance characteristics. Julia and this package ecosystem keep pushing the performance tremendously. So here I have a slide of various different benchmarks. The first one out here is, if you can see my mouse pointer, then the first one to the top left here is the computer language benchmarks game. It's one of the most comprehensive benchmarks of a number of different programming languages. And if you will notice, like Python and R and MATLAB don't even make it to this list here, because as they benchmark dozens of languages, the first screenshot only includes the fastest ones. And you have C and Rust and Fortran and Julia all in this sort of first few columns, and then you have things like .NET and Java and Swift and Lisp and Haskell and Go coming up as slightly slower. So Julia is one of those rare, actually probably the only dynamic programming language that is present on benchmark charts such as these. But if you look at some of the other libraries, if you're doing graph processing with Julia, it is actually more on par with some of the C libraries and significantly faster than Python libraries like NetworkX. Some of the machine learning libraries in Julia, like K-means, can often be 100x faster than similar algorithms in scikit-learn. One of my favorite examples is the Julia data frames library. In order to sort of load data from CSV files or databases as tables and then munch them and work with them at scale. So here's performance on a 50 GB data set, and Julia is actually as fast as almost as fast as Spark here. In fact, these benchmarks are a little bit dated. So Julia is actually right up there with some of these topmost data processing frameworks. However, all of these data processing frameworks have actually been written in C and C++, whereas Julia is written in dataframes.jl is written in Julia itself. Of course, if you're working in data science, you actually spend a lot of time loading data from CSV files, which is still the most popular format amongst data scientists and also engineers. And fast CSV loading is something that our community has focused on, and Julia is one of the few that actually has multi-threaded CSV reading. There's a growing collection of Julia books, and we mentioned some of them here, but there's at least 20 or 30 Julia books out there. If you want to learn Julia, if you just go to Amazon.com, and I haven't done this, so I don't know what I'm going to find here, but let's say if you go to Amazon.com here. Let me actually do the India version. So if, in case you're at Amazon.in, we go and look for Julia programming language. You'll see that a lot of Julia books actually pop up right there. So you could actually, have this book in your hands right as we speak. So there are books not only on Julia as a programming language, but also books that are focused on numerical computing or domains like optimization and image processing and data science and statistics and so on and so forth. One of the best things about the Julia language is its community and some of the tools that the community has built that are unique to the Julia language. You have Pluto notebooks, and Pluto notebooks are reactive lightweight notebooks. So if you have used Jupyter, you will know that Jupyter notebooks actually have global state, and sometimes you can order them, you can execute them out of order, and find that you're in a weird state. And that's why I always tell people that when you create a Jupyter notebook, make sure you run it from top to bottom and make sure it works. But Pluto notebooks are actually do not have that problem. They're actually reactive, and Pluto notebooks actually understand Julia code, and they will execute it in the right order always. So here on the left-hand side, you're seeing a little bit of the demo of what a Pluto notebook looks like. But notice that as you change, some of the things in there, the other cells that depend on something will change in real time. So as you change the value of n, some of the earlier cells are actually going to change. Now, what we can do is actually take all of these things within Julia and push them to the next level, right? So I'm going to transition and talk a little bit about machine learning. And the key idea here, especially in Julia, is that models are really programs, and that machine learning problems are really programming language problems, right? If you're a user of modern frameworks like PyTorch and TensorFlow, you will find out that as you start doing work that is more tailor-made to a domain that you're working on, to a specific class of problems that is new, unless you're using an existing image processing or an NLP library or a computer vision library, if you're trying to combine machine learning with scientific simulations, you actually need to be able to go beyond the tools that toolbar that frameworks like TensorFlow and PyTorch provide you. And Julia provides a flexible and fast system that makes it very easy to work with scientific machine learning. So broadly put, what Julia allows you to do is combine enormous data sets with distributed computing, with GPUs, and and Raspberry Pis, with all of the fundamentals of machine learning. The most fundamental thing within machine learning is a technique called automatic differentiation. All of you must be familiar with calculating derivatives. As engineers, you always know that derivatives give you the rate of change, and if you can calculate the rate of change, you can optimize the system. And machine learning at its core is an optimization problem. And this is where Julia really shines, because it can, in Julia, you can differentiate broad chunks of the Julia programming language, and that gives you, a technique called automatic differentiation, through which, if you have a Julia simulation that describes, a drug dosage calculation or a battery design calculation, then it will allow you to optimize over that entire simulation. So and I will actually talk about specific applications of this as we on one of my later slides to give you a feel for what it looks like. But if you look at some of the machine learning libraries, so PyTorch, for example, is written mostly in C++ and CUDA. TensorFlow is written mostly in C++ and Python. Julia is actually written 100% in Julia, and the dominant programming deep learning framework in Julia is a system called Flux. So if you go to fluxml.ai, you can see. Apologies, I always use dark mode on my browser, so this is not actually how the website looks. It will be much much nicer looking. But this is the Flux website, which talks about the Flux project and its ecosystem and the partners, and how to get started with with tutorials and all that stuff. All right, let's kill some of these windows. Uh-oh, I think I killed my presentation. All right. So just gonna go back to the slide that I was presenting here. All right. So Flux is a completely native Julia language implementation of various machine learning systems. Now, I wonder if if I can ask some questions to the audience. Is it possible for people to participate in the chat? Like if I go here and say, which programming language do you use? If people can participate in the chat, please, please give your answers, and maybe I'll request. I'll come back to this and see what people have answered. But also, please feel free to ask me some questions. I mean, I didn't mean this to be a complete monologue. I would love to be able to answer some of these questions as I go along. And I'm going to sort of keep coming back to the chat. Lots of Python users I see. Okay, so Java, we have some R users out here. So we really have a mix of many different kinds of users. Also say, what do you use Python for, right? Like, are you using it for machine learning? Are you using it for signal processing? Are you using it for engineering design? Are you a mechanical engineer? Are you a chemical engineer? Please let me know. Okay, I'll go back to the chat in a little bit. So please get it going. Oh, someone mentioned multi-threading, right? So Julia is actually the only high-level language like MATLAB or Python that is natively multi-threaded, which means that most users can actually leverage all their CPU cores simply by using Julia's built-in multi-threading. And I think this is pretty amazing compared to some of the other languages that are out there, that are like Python and R. I mean, right? Like, of course, C and C++ have multi-threading, and so does Rust and Go. But a high-level language like Julia, a dynamic language like Julia, actually I don't think there are others that have multi-threading in the way we do. And Julia's multi-threading is actually composable. So if you write multi-threading in your code and you call other multi-threaded libraries, Julia will actually orchestrate the work across all the different threads, across all the different packages, and not oversubscribe your course like you might with pthreads, for example. But one of the other things is that Julia supports NVIDIA GPUs and AMD GPUs and now Intel GPUs. So Julia has a very generic GPU computing framework, and that is fully abstracted away so that it can work with many different GPUs under the hood. So if a new GPU comes out tomorrow in the market, Julia will support it almost instantaneously. And some of the scientists, for example, at the Swiss Supercomputing Center have run over 1,000 GPUs in a parallel deployment. People are doing multi-physics simulations running AlphaZero, not the DeepMind AlphaZero, but the Julia implementation of AlphaZero that is out there. And we've noticed over 300x performance improvement in a pharmaceutical workload with Pfizer using GPUs. So I've talked about GPUs, multi-threading, performance, machine learning, right? And what brings it all together is differentiable programming, right? So everyone's thinking about machine learning, everyone's excited about it. But what you really want is to take some of those ideas in machine learning and combine them with broader programming language design. Excuse me. A technique that we refer to as differentiable programming. I would urge people to look at our paper at the AAAI Spring Symposium in MLPS 2020. It's a paper called I wonder if I can move this thing out of the way here. Oops, never mind. Right, so I would urge you to look at this paper called Generalized Physics Informed Learning Through Language-Wide Differentiable Programming, which talks about some of the ideas in much more detail that I am. Okay. So what is differentiable programming, right? It's, think of a function like a function foo, which has some of these lines here. And all we want to do is automatically compute the derivative of this program. If we can, if you remember my point, if you can compute derivatives, you can optimize. And if you can optimize, you can do machine learning and you can do optimal design and, uncertainty propagation and all kinds of interesting things that can save scientists and engineers, weeks and months of work. And, simply put, zygote.jl, a package that is maintained by, I should point out that flux.jl and zygote.jl are a couple of the packages that are actually maintained by Dhairya Gandhi, who's one of our core contributors in the Julia world and is actually based out of India. It's some of the core Julia capabilities are actually built and maintained by contributors in India. I'll also like to give a shout out to one of our recent engineers, Venkatesh Prasad, who recently joined us and is driving a lot of these kinds of technologies in domains like circuit simulation and physical simulation, where we bring tools like Zygote and automatic differentiation to do optimal design of many engineering systems and pharmaceutical systems, and some of the problems I spoke about earlier. So, if you know Venkatesh, then please, Venkatesh Prasad, then please reach out to him and learn more about Julia. You have a local friend right here on this call. Oh, I wanted to go back and see what's being discussed in the chat here. And we have all sorts of various things. And of course, we have Venkatesh Prasad here, who is now exclusively working with Julia. That's always fantastic to see. Please feel free to ask me some questions. I'm actually I actually prepared only enough slides to talk about for about 30 to 35 minutes. And I was hoping that people will have questions so that I can actually answer them live and talk about what you might be interested in. Okay, but differentiable programming is now disrupting scientific modeling and simulation in all these different domains: pharmaceuticals, engineering, chemistry, manufacturing, batteries, climate, you name it. Julia is being used in all of these different domains. Our colleagues at some of the best, the most widely known pharmaceutical companies are using Julia for designing drug dosages. So imagine that you have designed, you've done your clinical trial. How do you decide how much of a drug to give to a patient? Well, it turns out that you have to do a simulation that, models the impact of the drug on the patient. And that's an analysis that is actually carried out in a software called Pumas. Pumas is also another, Pumas is completely built in Julia with a lot of contributions that come from contributors in India at Julia Computing and Pumas AI, which is actually a partner company for us. And this software is being deployed at all the pharmaceutical companies as we speak. In partnership with Carnegie Mellon universities, we are designing new fuels and new electrochemical systems for new batteries. And making it easy to use, to design new materials using Julia. With Mitsubishi Electric Research Laboratory, we are working on designing new air conditioning systems. We are helping them simulate air conditioning cycles so that it's easy for them to test out new refrigerants or test or simulate the impact of an air conditioning system on a new building. And the way, what makes this problem really hard is that, the refrigerant in an air conditioning system, when you change your thermostat, will react on the order of seconds, but a building will, heat or cool on the order of hours or days or weeks, depending on how big a space your air conditioning and how big your air conditioning system is. And so in order to simulate them, it has been extremely hard. And until Julia came along, it was actually, it used to take weeks and months to carry out these simulations. We can now carry them out in hours. And so, as we have climate change happening, as the world is warming up, the demand for air conditioning is only going to go through the roof, and we need new environmentally friendly refrigerants in our air conditioning systems. We need new systems that are far more efficient than the ones that are in use today, and Julia is right in the midst of it. Teams at MIT and Caltech are using Julia for climate modeling, and I already talked about some of the new and upcoming applications in agriculture. But this is just the tip of the, this is just the, just the tip here, and there's just a lot more that is going on. One of the things that we do at Julia Computing is we develop a system called Julia Hub. So Julia Hub is a cloud-based system on which you can run Julia. Go to juliahub.com, you can create a free account and get started to explore, build, run, scale, and visualize Julia. In fact, I should just point out how to get there. So if you go to juliahub.com, you can go in, you can well, I'm already logged in here. You can go in, you can see, what kinds of jobs you're running, what kinds of applications you have, and all your data science workflows. And you can stay up to date on some of the new packages in the Julia ecosystem and what's going on. But it turns out our latest popular tag is Hacktoberfest, because, Hacktoberfest is going on. And if you participate in it, make a pull request to Julia or one of its packages, you might get a free Hacktoberfest t-shirt. And here are some of the most Julia popular packages in Julia. But let's go and see what some of this looks like. So if you go to the help section, you can see tutorials and how to run a Julia script. Simple codes like how to run them, how to launch. One of the amazing things about Julia Hub is that it runs on the cloud, so you can go in and spawn up a distributed cluster using that starts a Julia job, and you can run it with CPUs and GPUs, and you can run it at scale. It will tell you how much it costs, and you literally have a supercomputer at your fingertips. You can also set up the Julia package environments. You can upload data. You can work with all these things. All the data science workflows are beautifully implemented in Julia Hub, and it gets better by the day. You can edit with Visual Studio Code inside the browser here, and so on and so forth. Well, yeah. So here's some of the stuff around parallelism and data management. So I'm sure you can find this website on your own. Oh, one of the things I wanted to point out is Julia Sim, which is a specific tool that we built on Julia Hub for engineering simulation, modeling and simulation. So you can go and kind of get a feel for all the different kinds of things that we have in Julia Sim right here. And that's the API that's upcoming. But yeah, so there we go with the model library and everything. There's thousands of models that are available pre-trained within Julia Pro. Okay, so with that, I have run through my slides and I'm going to come back and take some questions. So yeah, please let me know if you have any questions right there in the chat, or reach out to. I should point out that if you're new to the Julia language, then what you do is one of the most amazing things is participating in the community, and you can go to the Julia Discourse, which where you can find, as a Python program, as many of you are using Python, you might be used to going to Stack Overflow. One of the things in Julia is that while you can find answers on Stack Overflow, often the answers exist on Julia's Discourse. So, please make sure to use, Discourse and search for anything that you're, interested in Julia. If you're new to Julia and you have a question, make sure that you search on the Julia Discourse to see if it was already answered, and only ask a new question if it has not already been answered. There's thousands of people in the Julia community out here. If you go to the Julia Lang website and go to the community section, you'll see that all the different places where you can get help on Julia. We have a very large and popular YouTube channel. So if you go there, this is the landing page for Julia, and please make sure to subscribe if you go there. And there are some amazing videos, including some of the most popular videos by 3 Blue 1 Brown from Grant Sanderson, as part of this the MIT computational thinking course. Oh, by the way, if so the best way to learn Julia is actually going to computationalthinking.mit.edu. And this is a class that is actually in progress right now. You can see the older versions of this class that were taught last semester, but this is a class that is in progress, so you can actually follow along online and learn Julia from Professor Alan Edelman, who's a professor at MIT and one of my co-founders and co-creators of Julia. And it's a beautifully created class with some of the most amazing examples and code snippets and demos and interactivity and everything else. So and covers a wide variety of topics. So there you go. Yeah, computational thinking.mit.edu is the name of that class. If you want to learn, yes, please. Sorry, I thought I heard someone.
No, sir. Please continue.
Okay, I was just going to show Julia Academy, which is where there are many other courses on Julia. And why does it want me to enroll? Okay, let's just enroll. Login. It's a free login. JuliaAcademy.com, completely free. You can create an account out there. And oh, this has taken me to the admin page. But there we are with all the courses. So, the computational thinking course is out here, as well as a basic introduction, data science in Julia, foundations of machine learning, Flux, parallel computing, just all kinds of different things. Yeah, so with that, I will actually stop talking. And if there are no questions, then I might hand control back over to the organizers.
Participants, any questions? You can unmute yourself and ask questions. No questions?
Hi, Arun here. Discussed about the computational thinking. Is it something specific about the Julia product itself, or is it something kind of a open forum, like where all kind of emerging technologies and developments are discussed?
It is computational thinking is actually a class that is a semester-long class taught at MIT. So if you're, a student at MIT this semester, then it's a class that you can take. But it's being live streamed, so anyone from anywhere around the world can join it. It covers a broad range of computationally interesting and relevant topics today. But it teaches you those ideas using the Julia language, because you can sort of get significantly better performance with Julia, and so you can actually sort of try out concepts at scale in real life in the class itself. But yes, it's not a broad forum to discuss. It's a bit narrower than what you just mentioned.
Okay. Thank you, sir.
Viral sir, this is Pushpa here. Hello.
Yes, please.
Yeah, whether Julia replaces Python?
Well, I mean, yes. So Julia is a complete programming language. So you can do everything in Julia. It's a completely general purpose programming language. So you can do everything that you can in Python using Julia. But of course, it replaces it in the sense that it is an alternative, but often many Julia users use Python and Julia together. And that's actually a great question. So you can actually call all your Python libraries from Julia using a package called pycall. So if you go to pycall.jl, you can see how you can call. So here's an example of calling math.sign from Python, and this just works in Julia. So you can call matplotlib, for example, from Julia. You can go both ways, but you don't get the speed benefits of Julia if you're calling Python libraries. So in that case, if you want all the benefits of Julia, you have to sort of use Julia all the way. But I hope that answers your question.
Thank you.
Any questions? Participants? Sir, I assume there are no more questions. Thank you, sir, for an informative session on Julia. We as researchers are excited by listening to the uses of Julia in different applications, such as fast data development, climate modeling to improve agriculture, and its capability to support multi-GPUs and new GPUs. Thank you, sir.
Thank you very much for having me.
Thank you, sir.
And please enjoy the rest of the conference. I'm sure there are going to be many other interesting talks. But do remember to download Julia. And with that, I'm going to sign off.
It's over to you.
Thank you.
Our next keynote session is on signal processing, machine and deep learning applications for research and innovation by Dr. Celia Shahnaz. Kindly be in the link. It will be started by 5:45. Another 5 minutes.
Hello, Gayatri.
Yes, ma'am.
ಒಂದು ಹಾಡಾದ್ರೂ ಆಡ್ತೀರಾ ಅಷ್ಟು ಬ್ರೇಕ್ ಅಲ್ಲಿ? ಅವ್ರು ಒಂದು 5 minutes ಆಗತ್ತೆ ಅನ್ಸುತ್ತೆ, ಮೀಟಿಂಗ್ ಅಲ್ಲಿ ಇದಾರಂತೆ. ಶಿ ಹ್ಯಾಸ್ ಟು ಜಾಯಿನ್. ಸೀಲಿಯಾ ಮೇಡಮ್.
ಹಲೋ
ಹಲೋ ಮೇಡಮ್,
ಹಾ
ಅವ್ರೊಂದು ಬೇರೆ ಮೀಟಿಂಗ್ ಅಲ್ಲಿ ಇದಾರಂತೆ, ಸೊ ಶಿಲ್ ಜಾಯಿನ್ ಅಂತೆ ಒಂದು 5-10 minutes ಅಂತ.
ಹಾ
ಸೊ ಇನ್ ಬಿಟ್ವೀನ್ ಏನಾದ್ರು ಗಾಯತ್ರಿಗೆ ಅದಕ್ಕೆ ಹಾಡು ಏನಾದ್ರು ಹಾಡಕ್ ಕೇಳೋಣ ಅನ್ಕೊಂಡೆ.
ಪಾಪ
ಇನ್ ಯಾರು ಇಲ್ಲ.
ಪ್ರಶಾಂತ್ ಕೇಳಿ.
ಯಾರು ಮ್ಯಾಮ್?
ಹೌದಾಯ್ತಾ? ನಂದು ಯಾವ್ದೋ ಒಂದು ನಮ್ದು ಇದು ಬಂತು, ಡೋರ್ಸ್ ಆರ್ಡರ್ ಮಾಡಿದ್ದೆ, ಅದು ಬಂತು. ಅದಕ್ಕೆ ಚಕ್ಕನ್ ಕೆಳಗ್ ಹೋದೆ, ಅದು ಡಿಸ್ಕನೆಕ್ಟ್ ಆಗೋಯ್ತು.
ಹೌದು, ಮುಗೀತು ಮ್ಯಾಮ್.
ಚೆನ್ನಾಗಿತ್ತಾ? ಕ್ವಶನ್ಸ್ ಏನಾದ್ರು ಕೇಳಿದ್ರಾ ಹುಡುಗರು ನಮ್ದು?
ಕ್ವೆಶನ್ಸ್ ಯಾರು ಒಬ್ರಷ್ಟೇ ಕೇಳಿದ್ದು ಮ್ಯಾಮ್.
ಓಕೆ ಓಕೆ.
ಮತ್ತೆ ನೀವೇ ಏನಾದ್ರು ಹೇಳಿ ಮೇಡಮ್.
ಇಲ್ಲ ಸರ್, ಪ್ರಶಾಂತ್ ಹೇಳಿ. ಪ್ರಶಾಂತ್ ವಾಯ್ಸ್ ಸರಿಯಾಗಿದೆ.
ಪ್ರಶಾಂತ್ ಇದಾರ ನೋಡ್ತೀನಿ ರೀ ಮ್ಯಾಮ್.
ಇದಾರೆ.
Yes, ma'am, I'm there. Good evening, ma'am.
ಗುಡ್ ಈವ್ನಿಂಗ್ ಪ್ರಶಾಂತ್. ಪ್ರಶಾಂತ್?
Yes, ma'am. Ma'am.
Can you? Yeah.
Yes, ma'am. ಯಾವ ಹಾಡಲ್ಲಿ?
ತೀರ್ಥ ವಿಠಲ, ಮೈ ಫೇವರೇಟ್ ಸಾಂಗ್.
ಒಂದೇ ಒಂದು ನಿಮಿಷ, I'll just set it up.
Okay.
Okay. I hope I am clearly audible.
Yeah.
Okay, just 1 minute.
Yeah, Prashant.
ಮ್ಯಾಮ್
ಹ್ಮ್
ಮೇಡಮ್ ಬಂದಿದ್ದಾರೆ.
ಬಂದಿದಾರಾ? ಪ್ರಶಾಂತ್.
Prashant, at the end you can sing then.
Okay, ma'am.
Yeah. Thank you, Prashant.
No problem.
I'll start, ma'am.
Yeah.
Celia, are you there?
Yeah, ma'am. Give me 1 minute.
Yeah. Hello.
We'll start introduction, ma'am.
Yeah.
Now I request Gayatri Hegde, research scholar, to introduce the keynote speaker, Dr. Celia Shahnaz, ma'am.
Thank you, Shweta. It's my privilege to introduce Dr. Celia Shahnaz. Celia Shahnaz, senior member IEEE, fellow IEB, received PhD degree from Concordia University, Canada, and she's currently a professor at Department of IEEE, Bangladesh University of Engineering and Technology, Bangladesh. Ma'am has published more than 150 international journal conference papers. She is a recipient of Canadian Commonwealth Scholarship and Bangladesh Academy of Science Gold Medal for her contribution in science and technology. Her research interests include the areas of signal processing for speech analysis and speech enhancement, audio-visual recognition for biometric security, control system, robotics, pattern recognition, machine learning and deep learning for audio, video, biomedical, power signals, multimodal emotion recognition, and humanitarian technology. She has received the Best Paper Award in IEEE Biomedical Engineering, Computer and Information Technology for Health Conference, Biomedical Engineering track at TENCON, and at IEEE WIE Conference in Humanitarian Challenge track, and the Best Interactive Post Award at ICI VPR 2007. She is the recipient of 2021 Inspiring Women in Academia Award from Bangladesh Brand Forum. She has held various posts at IEEE, like Chair, IEEE SPS Women in Signal Processing Committee, Liaison of IEEE SPS to IEEE Women in Engineering, IEEE WI History Committee, IEEE Educational Activities Board, Faculty Resource Committee, IEEE New Initiative Committee, IEEE WIE Senior Member Elevation Drive, IEEE WIE, IEEE USA Coloring Book featuring 25 Women Subcommittee, IEEE WIE V Power Subcommittee Chair, IEEE WIE Workshop Subcommittee, Women in Site Working Groups, Communication Chair, IEEE Site Steering Committee, IEEE PES Women in Power Art and Representative, IEEE Region 10 WIE Coordinator. She has more than 20 years of experience in leading impactful technical, professional, educational, industrial, women empowerment and humanitarian technology, power and related projects at national and international levels. I welcome you, ma'am. Now I request you to take over the session.
Thank you, Gayatri, for such a humble introduction. Thank you, Deepa madam, and thank you all the organizers for inviting me. And let me share my screen very quickly. Yes, hope you can see my screen, right? Hello, Shaila? Hello, Gayatri.
Yes, ma'am. Yes, ma'am.
Yes,
Now we
ma'am.
can.
Yes, ma'am.
Yes, ma'am.
Okay. Okay, thank you very much.
Yes, madam.
Yeah, for this great initiative by your university, you know, and in the pandemic, we are taking such initiatives, and that's a very good thing because we want to disseminate information and knowledge to the people around us, despite the pandemic, you know. And I like to thank the volunteer who have prepared the poster. We have to recognize every single volunteer. They are our silent heroes. And if you look at my topic, it is signal processing machine and deep learning application for research and innovation. And let me tell you, you know, it's a great honor to get elected as 2022 IEEE WA Committee Chair-elect, and I will be chairing IEEE WA Committee in 2023 and 24. And it has been publicized to the IEEE election website, and also IEEE WA newsletter has given this announcement to every WA members around the world. I express my sincere gratitude and support to everyone, you know, and it's a great honor that we will be working together for many years to come, and this is just a beginning. And this is just a brief bio what Gayatri has introduced. I will request you to visit my website www.celiashanaj.com to know more about me and to let me know how I can help you in your research and innovation. And I also request you to visit my Google Scholar citations to really know that despite so many limitations, so many problems of funding opportunities, less PhD students, because I serve as a professor in the Department of AAA, Bangladesh University of Engineering and Technology. This is the highest ranked engineering university in the country, and majority of our students are going to United States and Canada for their PhD. And since I work in deep learning, and there are a lot of problems, there are a lot of problems in computational facilities. Still, how my students are working so hard and providing and choosing emerging topics to publish in impactful journal and conferences. That's an important story to tell. And that's an example for the young students and faculty members. And I like power of networking and innovative ideas, in my every step, even this human chain that was led by me. I was very innovative and inspired everyone to be innovative. And left side actually shows the societies, technical societies where I'm involved for my technical activities, starting from my heart. My heart is women in engineering. And also, since I live in subcontinent, we all live in subcontinent, and my grandpa, maternal grandpa, was in Kolkata 60 years back as a lawyer. So as a privileged person, I always think to provide opportunities to the underprivileged community. That's why I always, in my research, I try to connect my research with one of the United Nations Sustainable Development Goals. And I'm chairing currently Women in Signal Processing Chair of whole of Global SPS, and we do a lot of panel to promote diversity and inclusion. And recently in a flagship conference of signal processing, I inspire you to join there, ICAS 2021. We invited our president, Kathy Land, and also the past president, Leah, and also speaker from NASA on robotics, so that we can do interdisciplinary research. It is important for such keynotes. Also, we have gathered our SPS president, future president, our VPs, Global Women in Engineering Chair Jennifer, and different technical societies, leads, and the role models, industry expert from IBM, to know the best practices to promote diversity and inclusion in technical societies, which is very, very important. And also, let me share you my very impactful research. One was denoising of ECG signal, because ECG, you know, electrocardiogram signals, and it has noises while collecting through the probes. And it is important to reduce the noise so that doctors can diagnose it for detecting ECG arrhythmia. This is the paper which is high cited, the more than 355 citations. And also, this is a paper for one-dimensional signal pitch estimation for fundamental frequency from noisy environment, and you can leverage this technology for harmonic distortion in for power signal. It has been published in IEEE Transactions. Also, I'm caring about hearing impaired people because they need hearing aid devices. So this is speech enhancement based on statistical modeling, and that has been published in IEEE Transactions. And I really urge you to read those papers and come back to me how those models can be used in your work. And another another one-dimensional biomedical signal is electroencephalogram EEG. You know, EEG, from EEG, we have developed a seizure activity classification scheme, and this has been published in 2021. And also, since I work with different dumb community, while I was talking and thinking about sign language detection, alphabet recognition, I found that everything in English, but I speak Bengali. So, and it's a 5th or 6th ranked language in the whole world. And we fought for our mother tongue in 1952. 21st February. It is International Mother Language Day, celebrated all over the world. And so I felt commitment to develop this Bengali Sign Language alphabet recognition. And my students have developed it. You can see the images, and we have applied VDD19 to detect this alphabet very accurately. And also, I was working with tuberculosis. Detecting tuberculosis, looking at the X-ray image, is a troublesome always, and it has a lot of errors. So that's why we have taken an ensemble of different neural network and deep learning architecture like DesNet, ResNet, Inception, and V3, so that we can have an ensemble. And also, we didn't forget about the machine learning approaches. We have taken an ensemble from there, and we have combined the two ensembles so that we can have a better detection of tuberculosis from the chest radiographs. And We also are applying our neural networks, deep neural networks in pneumonia detection from X-ray images. And for pneumonia and COVID, both the cases, the oxygen saturation level decreases. So looking at the X-ray images, it's very difficult to really know which is pneumonia, what is COVID. And this COVID came, and Bangladesh faced third waves, and India faced inhuman catastrophe for COVID-19 detection. So this is our time to help the doctor to use the X-ray images and do automatic detection of COVID positive or COVID negative. And my students, naturally, although they are disconnected, they were sent village home because of the COVID, and all, despite connectivity issue, they gathered, saw a lot of images, and they started to compare the CT image, X-ray image, and ultrasound images, finally they have developed a network, developed a COPSCAVE network, and find and detect COVID-19 from multimodal images. And it has been recently published in IEEE Transactions on Artificial Intelligence. And the tuberculosis work has been recently published in IEEE Access. You can read those papers and let me know how the developed architecture can be deployed in your work, no matter where, because the deep learning is a tool. It can be applied to speech, image, video, power signal, anywhere, any data. So we should not start from the scratch. Let us have a Zoom meeting to have a collaboration so that the network or architecture already developed can come for your use, for your research, to accelerate your result, And I always encourage my students to participate in the global competitions. Like SPS has a competition called ICIP VIP Cup competition. Last year in 2020, October 2020, ICIP has launched a database and competition for distortion classification of laparoscopic videos. Laparoscopic videos has a lot of distortion, and for that my students have developed a DISNet network, and this is the picture of this, some glimpse of laparoscopic video images. And why we will do, because if we want to do the surgery through the manual handling, there may be a lot of surgical errors. So, and that can lead to fatal death. That's why we want to automate the process of distortion to help denoising and take the mitigation plan. So for this, we have done a signal processing based feature extraction, and then developed a shallow neural network to maximize accuracy and minimize the time. And this is just a block diagram. We are taking the images from the video frames. We have extracted the feature array and send it to the shallow neural network to classify what type of distortion present in the video. And this is the feature extraction. After we take overlapping image frames from the video, we try to detect white Gaussian noise, smoke level, and uneven illumination, blur level estimation, and then we gathered all the features and a feature array. And these are your examples of white Gaussian noise present, and you can see the equations and noise variance is a key factor to characterize an image polluted by white Gaussian noise. And also, if you look at this picture, it's a smoky. And we did histogram analysis and median of mean values taken to be observed, because smoky frames tend to have less median value. That's a good indication. And also there are uneven illumination. You can see this picture, and the ratio of luminance mean to range is a great indicator for such a change in illumination and show the uneven illumination. And if you look at this picture, this is a blur level estimation, and the blur image will show low variance and less edges. And this blur coming from different reasons, camera hardware, slow shutter speed, and longer focal length, like that, And once we have extracted the feature array, you can see the shallow neural network. From input, we are sending it to the convolutional network, and then sequential self-attention layer. Of course, we have used LSTM, dense layer, batch normalization, and then to get the decision. I request you to visit our paper published in IEEE Explore to know more about the architecture of the shallow neural network. I'm just telling you in layman terms so that you can quickly get the points, And for any biomedical data, you will be always requested, you will be always asked about the data set. There are total 800 videos, and there are total 10 classes, 4 individual classes and rest of 6 classes, combination of the individual classes, okay? And if you see the data structure, we don't have data imbalance, and we need some data preparation. If you look at this picture, that's a pretty interesting. That's the learning curve. If you see the y-axis accuracy, x-axis the epoch or iterations, and similarly we have plotted loss, model loss in the y-axis with respect to iterations. We can see both for training and validation, the model accuracy increases and model loss decreases. That's a very good claim. And if we see our performance in terms of accuracy, loss, and to justify how accurate our model is, we have taken Cohen-Kappa statistical score. We can see for both training and validation, our accuracy is high and loss is low, and Cohen-Kappa score is also very high. Then we have exposed our method to more challenges, like how to evaluate the performance on unseen data, and that's why we have our accuracy, and we can see even with unseen data, our accuracy and Cohen-Kappa score did not decrease. That's a very good claim. And our students have compared the method with the other teams in the competition. We can see that our accuracy reached to 3rd rank, but in terms of time, fastness, our team is ranked 1st, which is very important for a surgical error to be detected so that the mitigation plan or denoising can be done very quickly to really help the surgery. And also, we are working on abnormality detection in musculoskeletal radiographs. And for that, because why musculoskeletal radiographs? Because 1.7 billion people are suffering for that. And we are trying to automate the detection process. And for that, my students have developed this Capsule Network, and it has been published in IEEE Access. This is just a proposed architecture. Convolutional 1, convolutional capsule layer, class capsule. If you see this structure, you can understand it. You can understand with different sizes, and we have taken pre-processed image, go to the convolution 1, then go to the class capsule, then routing by agreement algorithm to detect whether it is normal or abnormal. And we have also plotted loss accuracy curve. We can see that the red one is our accuracy and black one is our loss, that we are providing higher accuracy with lower loss compared to the conventional DanceNet, which has blue accuracy and purple loss. And that's a very good claim for our method. And that I have been a strong advocate of women in terms of research and innovation, but I found that our women are suffering from skin cancer, and they are reluctant in doing the diagnosis. These are digital images of different types of skin cancer. I thought that let us apply our deep learning models to really detect it very quickly and accurately. But we started working with 10,000 data, but there is a challenge. It is a 7-class classification problem, and it has data imbalance. In some cases, data is low, in some cases, data is very high. So for this, we have utilized the data augmentation, and these are our applied model: Inception V3, VGG16, VGG19, ResNet 50 conventional features. This is a typical model architecture of Inception V3. We did convolutional layer, average pool, max pool, concatenational layer, dropout layer, fully connected layer, and softmax. And these are the conventional features, color features, image quality. Histogram analysis in red, green, blue, hues, saturation, Y, CBCR. So as expected, we have compared our result in terms of accuracy as expected compared to the conventional features. Our models are providing better results. So I really request you to inspire your students and to join SP Cup competitions globally and VIP Cup competition. You know what? That I actually I started supervising this SP Cup competition since 2015. My student was ranked 5th, and they were very upset. I told them no need to be upset. You can let us work more on it. And we published 3 journal papers. And what? The outcome is one student got PhD in admission in University of California, Riverside, USA, and another got admission in Princeton University. Princeton University is an Ivy League university. If you look at this topic, in SP Cup 2020, my team was ranked 4th, and VIP Cup 2025 team was ranked 5th. I told them this is a way to increase your coding skill and to know an emerging topic. And from the first topic, we can utilize this topic to deploy medicine in the rural community in the post-COVID era. And also for the VIP Cup problem, we can implement such techniques in the junction of our hospitals and different public offices, And let me tell you, Madam knows it very well. And it's very much related to my research. And for my research motivation, I launched this Women in Engineering conference in the area of electrical and computer engineering for the first time in history in the world in 2015 in Bangladesh, And I remember participants and authors from Bangalore visited there and attended the program. And then we started collaboration beyond borders. Bangladesh and Pune, Bangladesh and Uttar Pradesh, Bangladesh is Thailand, Bangladesh and Bangalore, and Bangladesh is Bhubaneswar subsection, and also join because in these conferences there are a lot of papers related to biomedical signal processing, machine learning, deep learning, because it indicates the interest of the people. Please be part of this amazing initiatives of huge number of authors, reviewers, speakers, industry expert, and we did Women in Engineering International Leadership Summit. And also I was general chair of TANSIM 2020. That's the second largest flagship conference. And I was general chair, and last year when everything was closed, as a general chair, I motivated my volunteers. And also in TANSIM, while handling more than 1,000 papers, I found that a lot of papers related to signal processing, machine learning, and deep learning. That's why I felt more committed to do research and innovation in those directions to bring benefits to the community. IEEE President Toshio Fukuda was the chief guest in TANSIM. And also we did International COVID-19 Congress for the first time in the world, and where our engineering and medicine biology researchers, our signal processing researchers has showed a great deal of work to handle COVID. And also Toshi Fukuda was chief guest also for the Congress. And recently amazing thing happened. Bangalore section was a very great partner of this event. International Women in Engineering COVID-19 Congress. I'm really grateful to Deepa ma'am and Dr. Anundi and all women in engineering volunteers in Bangalore. And we really see how research innovation and work-life balance has been done by COVID-19, during COVID-19. And we also saw there that artificial intelligence, machine learning, and deep learning are playing a huge role in handling the COVID-19 using technology. So I want to tell you, we have to really consider diversified leadership. And that's why we ran uh, to our program in Region 9, connecting, and I didn't connecting our speakers from India, Tunisia, Malaysia, Africa, from everywhere. And also recently we have done collaborative event between WA Bangladesh and also between WA Brazil. And that's why it is important for us to do such collaboration, to move beyond the border, discuss about our research topic and innovation, and discuss our academic and industrial collaboration, which is very important because in the subcontinent, our problems are unique. So we should provide the unique solution, and we should not start from the scratch. That's my only thing. And these are some hours, and it's a great honor. It's a list of hard work, list of commitment, and also the group award, our WA affinity group, and that became the best one in the whole world and best in region. And also WA student branch, for which I'm the founder, became best one in region 10, best, and became best in the whole world. Actually, we did a lot of technical events that way you are doing. I'm proud of you, and I'm blessed that I am a mentee of Dr. Deepa ma'am. And since maybe 2011, and in 2012, I first met her. And, and as a first female chair of section in its 25 years history, I had the honor to receive this MGS celebration banner from Director Cooksin, and that has increased my motivation more, engagement more, and I led my section to win IEEE MG Outstanding Large Section Award. We have really organized a lot of conferences, area-specific conferences, technical activities, young professional activity, women in engineering activities, entrepreneurship, industry, and a lot of activities, conference activities. And it is always a great honor to receive the awards for my mentees from IEEE President Jose Mura and other leaders. So I have one final thing to tell everyone, just apart from my core research, that why we will do research activity, why we'll inspire each other, because, just give you two examples. Our engineering medicine biology chapter, society chapter in Bangladesh has received 2020 IEEE EMBS Regional Outstanding Chapter Award. Only 2 chapters have received it, one from Bangladesh, another from Latin America. How we have really worked hard to really enhance the visibility of Bangladeshi researchers. I can say subcontinent researcher. I can say region 10 researcher to the rest of the 9 IEEE regions. And also signal processing chapter, for which I'm the founder, has received chair of chapters. And also we have organized distinguished lecture programs and also winter school on different emerging topics. So I'm really appealing to Deepa ma'am and everyone to really become part of technical program committee members, send your papers. We are doing co-located 5 conferences. The week on EC for the 7th time, Piacon related to power, energy, industry activity, Ryacon related to robotics and automation, SPICSCon related to signal processing, photonic and communication, BESITCon related to engineering, medicine, biology. You know, these are 5 conferences that covers many technical areas. Deadline is approaching, will be extending up to October 30. I will request you to send your good quality papers and become part of this amazing initiative. Maybe next year we will do this 5 co-located conference in different society chapters of Bangalore. And this is very important if your university wants to be part of it. I will be discussing with Deepa ma'am with it, how we can really jointly run this mega initiative, you know, and it will reach benefit to thousands of members of Bangalore. Where it is, and we can involve a lot of volunteers in our research and innovation and to make a change. And finally, I want to thank you. And I believe we can change the world because we are engineers. And visit my website, www.celiashanas.com. I want to congratulate you for your conference. I have seen the program schedule. Your speakers are so scholarly and your paper quality. I have seen the titles are very emerging researcher coming. You have tried your level best, and we have to always try our level best, but it is always important to cooperate with each other, unitedly work each other to bring visibility of this subcontinent researcher to the rest of the world, because we have a lot of silent heroes and nobody knows us. We have been working for many years, but nobody knows us. It is a great honor that I had now the responsibility to recognize every one of you, and we should focus our researchers, scientists who are an important part of IEEE and non-IEEE. So we can make a change, and you never think you are from a small college. I never thought that I'm from a small country, because, you know, the research, innovation, merit, accomplishment, those cannot be small. A person should be evaluated by those, and actions will be spoken. You know, sometimes position will be delayed, award will be delayed, and what will not be delayed, your spirit, your energy, your passion. You know, that is important. But what we have to do, we have to combine all our passions. We have to share our resources. We have to quickly do very Zoom meeting to discuss our topics, to share our networks, to share our architectures, to publish joint authors between Bangalore and Bangladesh. This is very important. This diversity in research and innovation is very important. So I will be talking with Dr. Deepa ma'am that how we can really implement it, and I'm really meaning it. It's not just a keynote talk for me, it's a vision from my side, and I want to empower every one of you. I want to listen from every one of you, and I want to help every one of you. Thank you once again for inviting me and giving me an opportunity to share my recent research, especially the COVID-19 research I was very passionate about, and I had a dream to publish it, and hope we can do more. Thank you once again. Take care and stay blessed. Have a wonderful journey.
Thank you,
Any
madam.
questions? Hello, Pushpa. Any question, anything related to research, anything? Pushpa, you are muted.
Unmute. Host has muted me. Phone.
Ma'am, you are now unmuted, ma'am. Now.
Okay. Ma'am, how are you? Happy to see you.
Yes, I've become more fine seeing you. You are so energetic.
Thank you.
ಒಂದ್ ನಿಮಿಷ ಫೋನ್ ಮಾಡ್ತೀನಿ ರೀ, ಒಂದೇ ಒಂದ್ ನಿಮಿಷ.
Deepa ma'am wants to.
Deepa ma'am.
Yeah, organizers, hello Celia, organizers had muted me, so I could not, I'm trying to unmute, it was not happening. Thank you so much for joining us, and congratulations on becoming the WIE committee chair-elect for for the year 2022. We are very happy and proud that a person from Bangladesh, our own region, has become the WI committee chair. We will work together, Celia,
Yes,
and
ma'am.
do research together.
Yes, ma'am. Yes, ma'am. It is our responsibility to bring visibility of our every woman around us.
Yes.
Otherwise, you know, if that's my thing, that we will keep on working hard, but you know, we need recognition, you know, and it's possible. It is important that anyone from subcontinent, if anyone from subcontinent can work hard, then we all should come together.
Yes.
That I may not be chair, I will be chair 2 years, right? After that, who is that? It's you. We have to empower, we have to remain united, and so that we can find our next leader, you know. So that is very important. And this change should continue. We should create our own leaders, and we should give value to the most hardworking people. That's important.
Yes. Thank you so much, Celia, for sharing your time and your research.
To personally say thanks to Deepa ma'am and every volunteer who really did a great job and who really supported me, no matter what. It's a time to say thank you, and it's a time to tell you personally that if you need any help, just send an email to me with a copy to Deepa ma'am so that we can work together. It's important. Thank you very much.
Thank you.
Yeah. Any queries, participants? Any queries?
I think they are tired. We are working from 8 o'clock in the morning. We started at 8.
Yes, and I'm also in a different international program. I just quit from there to join it, and I will join their team.
Okay.
Thank you, ma'am, for your wonderful session on signal processing, machine learning, and its application in healthcare. That too during this pandemic COVID-19, about the pneumonia, tuberculosis, and also giving us a motivation to do research or the collaboration. Thank you very much, ma'am.
Most welcome.
So now we have come to the end of the second day ICInPro 2021. Tomorrow morning session starts at 10 a.m. with the keynote address by Shailesh Sakri, that is about unwinding Alexa. So I request everyone to join 10 minutes prior to the session with the same Zoom credentials. Thank you, one and all.
Gayatri, 1 second. I asked Prashant to sing a song. Okay, if he is ready, let him sing me. Because I already told him.
Yeah.
Prashant.
Good evening, ma'am.
Refreshing.
Yeah.
Good evening, Celia, ma'am. Nice to see you after the last conference. Let me see if I can get my video on. I think I can. I hope you can see me.
Yes.
So yeah, let me quickly. देव विठ्ठल देव पूजा विठ्ठल विठ्ठल क्षेत्र विठ्ठल विठ्ठल क्षेत्र विठ्ठल माता विठ्ठल पिता विठ्ठल बंधु विठ्ठल गोत्र विठ्ठल बंधु विठ्ठल गोत्र विठ्ठल विठ्ठल क्षेत्र विठ्ठल विठ्ठल क्षेत्र विठ्ठल गुरु विठ्ठल गुरुदेवता विठ्ठल गुरु विठ्ठल गुरु विठ्ठल गुरुदेवता विठ्ठल निधान विठ्ठल निरंतर विठ्ठल तीर्थ विठ्ठल क्षेत्र विठ्ठल तीर्थ विठ्ठल क्षेत्र विठ्ठल नममणि माज नममणि विठ्ठल सापडला म्हणून कणिकान म्हणून कणिकान पाडनाई 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 तीर्थ विठ्ठल क्षेत्र विठ्ठल देव विठ्ठल देवपूजा विठ्ठल तीर्थ विठ्ठल क्षेत्र विठ्ठल तीर्थ विठ्ठल क्षेत्र विठ्ठल तीर्थ विठ्ठल क्षेत्र विठ्ठल. Thank you.
Thank you, Prashant.
Thank you, Prashant.
Oh, wonderful. Which raga it is?
This is based on Hindustani classical rock called Ahir Bhairav, but little bit of mix and match is there.
Yes, it's not a pure Hindi. I can see that sounds.
Yeah, it's in Marathi.
Marathi.
Yes.
Bhimsen Joshi's favorite song and my favorite song also. Every now and then I'll ask him to sing this song.
Okay, great.
He's a very good singer, learning music also, in spite of his busy schedule.
Okay, great, great. That's very important. You know, in signal processing, there is another big research area, music signal processing. So Prashant, you can also do well in that area because you are good at music.
Yeah, absolutely, ma'am. There are plans after my PhD.
Yes, because there are a lot of artificial intelligence and deep learning you can apply for chord recognition, automatic chord recognition.
Correct.
So I really love the song and it's a very refreshing, especially the ragas. That's very important because we can have a different drum beat music, but I like, since I am a Tagore singer, you know Tagore, right? Rabindranath Tagore.
Rabindra Sangeet.
Yes, yes. I'm from the very beginning of my life as a Tagore singer, but Tagore has a lot of raga also, depending on the different seasons. And those are not only Bangla, there's a mix of Sanskrit and other. And those are very, anyway, your song was very, very soothing for the mind. And hope I could understand the lyrics better than I could get it. Anyway, although I could not understand the lyrics, the music was so good. It really touched my heart. Thank you.
Thank you so much, ma'am. Thank you for the wonderful words. Thank you.
Take care. Thank you. We have to really do such activities. You know, we are not robots. We need it.
Yes. So a nice way to end the day's program. Thank you so much, Celia, and thank you so much, Prashant.
Thank you, ma'am.
Yeah, we can end the session. Tomorrow morning, I request all of you to join at 9:45.
Yes, ma'am.
Yes,
Okay.
it's an honor. Thank you.
Bye, Cecilia. Take care.